students, welcome back to our YouTube channel Google Baba. Today we are going to learn trigonometry formulae and their identities also. Now first I will show you here this right angled triangle ABC and angle ABC is equal to 90 degree. Therefore, remaining angle A and C, these are complementary angles. Complementary angles means the sum of their measures is 90 degree. Therefore, when I write here measure of angle C is equal to theta degree, then the measure of angle A is 90 minus theta. Now here, first I will show you trigonometric ratios and their formulae. First one, that is sin theta. Sin theta is equal to opposite side of angle theta. Opposite side of angle theta. I will write here in short, opposite side of theta upon hypotenuse is equal to, look here, opposite side of angle theta, that is AB. So we write here AB upon hypotenuse. Hypotenuse, this is right angle, so this is hypotenuse. Therefore we write upon AC. This is for sin theta is equal to opposite side of theta upon hypotenuse of this right angle triangle. Therefore is equal to AB upon AC. Then we write our second trigonometric ratio, that is cos theta. Cos theta is equal to, now here adjacent side of theta upon hypotenuse. Now here we put values, that is adjacent side of theta. Adjacent side of theta, this is adjacent side, this is also adjacent side, but this is hypotenuse. It has a name, and therefore adjacent side of theta, that is BC, we write here at numerator upon hypotenuse, that is AC, that is opposite to right angle. Then we write here third ratio, that is tan theta. Tan theta is equal to opposite side of theta upon adjacent side of theta. Opposite side of theta upon adjacent side of theta. Adjacent side of theta is equal to, we write here, look here, now opposite side of theta, that is AB here, upon adjacent side of theta, that is BC. Okay, this is our third ratio. Then fourth ratio, that is multiplicative inverse of sin theta, that is cosec²θ. Cosec² is equal to, that is completely reverse. Look here, sin theta, opposite side of theta upon hypotenuse, that is reverse means multiplicative inverse. Hypotenuse upon opposite side of theta is equal to, now here look this, now hypotenuse opposite side of right angle, that is AC, upon opposite side of theta, that is AB. That is our fifth trigonometric ratio. Sec² is equal to, that is completely reverse of cos²θ, that is hypotenuse upon adjacent side of theta. Therefore, we write here, look here, this is our right angle triangle. Hypotenuse opposite side of right angle, that is AC here, AC upon adjacent side of theta, that is BC. Therefore, AC upon BC. This is the fifth one. Then sixth, that is cot²θ. Cot²θ, that is multiplicative inverse of tan²θ. That is cot² is equal to adjacent side of theta upon opposite side of theta. We write this way, formula is equal to, now here cot², adjacent side, that is BC, adjacent side of theta, that is BC, upon opposite side of theta, that is AB. Trigonometric ratios of complementary angles. Now this is right angle triangle ABC, and angle ABC is equal to 90 degree, that is right angle. Therefore, angle A and angle C are complementary angles, means sum of their measures is 90 degree. When we take angle C is equal to theta degree, then angle A is equal to 90 minus theta degree. Sin theta is equal to cos 90 minus theta. Look here carefully, that is sin theta means opposite side of theta, that is AB. Upon hypotenuse, that is AC. When we find value of this cos 90 minus theta from this figure, then cos 90 minus theta means adjacent side of 90 minus theta, that is AB, upon hypotenuse AC, means value of sin theta and value of cos 90 minus theta both are same. Then second formula, that is cos theta is equal to sin 90 minus theta. Now look here, now cos theta, when we take cos theta, then adjacent side of angle theta, that is BC, upon hypotenuse AC. This is formula and we put values here. Same way for sin 90 minus theta means opposite side, that is BC, and hypotenuse AC, means values are same. Then third one, that is we write tan theta. Tan theta is equal to cot 90 minus theta. 90 minus theta. Then we get same ratio, same way. Look here. Tan theta means opposite side upon adjacent side. Opposite side upon adjacent side means AB upon BC. When we take cot 90 minus theta, cot 90 minus theta, that is adjacent side of this 90 minus theta upon opposite side means AB upon BC. Now next one, that is fourth, here cot theta. Cot theta is equal to tan 90 minus theta. 90 minus theta is equal to, look here carefully, now cot theta. Cot theta means adjacent side of theta. Adjacent side of theta, that is BC, upon opposite side of angle theta, that is AB. When we take tan 90 minus theta, tan 90 minus theta means opposite side, that is BC. 90 minus theta, opposite side, upon adjacent side, that is AB. Means we get same value for cot theta as well as tan 90 minus theta. Then fifth one, that is a cosec. Cosec theta is equal to sec 90 minus theta. 90 minus theta is equal to, look here, now we take cosec theta. Now here we take cosec theta. Cosec theta means hypotenuse. Hypotenuse, that is opposite side of 90 degree, that is AC here. Means cosec theta is equal to hypotenuse upon, here opposite side of theta. Opposite side of theta, that is AB. Opposite side of theta, that is AB. Now for sec 90 minus theta, hypotenuse upon adjacent side of 90 minus theta, adjacent side AB. So AC upon AB, same value. Now the next one, that is last from these complementary angles, trigonometric ratios for complementary angles. Here we write sec theta. Sec theta is equal to cosec 90 minus theta. Cosec 90 minus theta. Now look here carefully. Now sec theta means hypotenuse, that is AC. Hypotenuse upon adjacent side of theta, that is BC. Same way for cosec 90 minus theta. Cosec 90 minus theta, this 90 minus theta, hypotenuse upon cosec 90 minus theta means hypotenuse upon opposite side of 90 minus theta, that is BC. Therefore we get same value of sec theta as well as cosec 90 minus theta. We say identity, that is sin square theta plus cos²θ is equal to 1. Now this identity we reduce into another two formulae, that is, look here, sin²θ we keep as it is here, and when we take this plus cos²θ to the right side, then becomes sin²θ. Sin²θ is equal to 1 minus this plus becomes minus cos²θ. Sin² theta is equal to, we take this plus cos²θ to the right side, then becomes 1 minus cos²θ. Same way, we take sin²θ to the right side, this to the right side, therefore we obtain cos²θ is equal to 1 minus sin²θ, 1 plus tan²θ is equal to sec²θ, sec²θ. Now this also we reduce into another two forms, like see here, we take tan²θ to the right side, therefore plus becomes minus, therefore sec²θ minus tan²θ. Then we also convert this by taking 1 to the right side, therefore tan²θ is equal to sec²θ minus 1. Then next one, next identity, that is 1 plus cot²θ. 1 plus cot²θ is equal to cosec²θ. Cosec²θ. Same way we change like this, means here 1 is equal to sec²θ minus tan²θ. Same way we take this cot²θ to the right side, then becomes minus. Then same way we take 1 to the right side, then becomes minus. That is sin²θ. Sin² is equal to 1 upon cosec²θ. 1 upon cosec²θ. Then sixth one, we change this. Cosec² is equal to, we write 1 upon sin²θ, means we interchange the positions of sin² and cosec². Then next one, that is, we take this together, sin² into cosec². Sin² into cosec². Sin² into cosec² is equal to 1. Cos² means 1 upon sec². Same way we change here positions, that is sec² is equal to, we change positions, that is 1 upon cos². Then third one, that is product of these two, that is cos² into sec² is equal to 1, means we take product of these two, therefore cos² into sec² is equal to 1. Then next one, that is tan² is equal to 1 upon cot². Same way we here also change positions of tan and cot, therefore we get here cot² is equal to 1 upon tan². Means this way we obtain many formulae from one formula. Then next here we write sixth one, that is, look here properly, that is product of these two. that is tan theta into cot theta, product of these two is equal to 1. Next formula, that is tan theta is equal to sin theta upon cos theta upon cos theta. Very, very important formula. Then next one, that is cot theta. Cot theta is equal to completely multiplicative inverse of this above, cos theta upon sin theta. Trigonometric ratios of compound angles, those are commonly used by students of 11th and 12th as well as students of foundation course 9th and 10th. Look here, trigonometric ratios of compound angles. First one, that is first sin A plus B. Sin A plus B is equal to sin A into cos B plus reverse here cos A into here cos A, here sin B. Okay, then next one, that is instead of plus we write there minus, sin A minus B. Sin A minus B, only we put here minus sign, here we put here minus sign, remaining is same, means that is sin A into cos B minus cos A into sin B. That is the second formula. Then third one, that is cos A plus B. Very, very interesting formula. Cos A plus B is equal to cos A into cos B. Look here, then we put here minus, when here plus then we write here minus, then here sin A into sin B. Okay, this is third one. Then next formula, that is cos A minus B is equal to, only we put here plus sign, that is cos A into cos B plus we write same, here sin A into sin B, this way. Then tan A plus B, here tan A plus B, tan A plus B is equal to, look here, tan A plus tan B, tan A plus tan B upon 1 minus, here plus we write here minus, what is tan A into tan B. This is for tan A plus B. Same way we obtain formula for tan A minus B. When A minus B, then we put here only plus sign and here minus sign, reverse, completely reverse. That is, look here, tan A minus tan B, means here minus here, and here we write plus, means 1 plus tan A into tan B. Now here when we take B is equal to A, means instead of this B, here B, when we take here instead of this B, when we take A, then A minus A 0 means tan 0. But when we take here B instead of B, when we take A, then A plus A 2A, then what happens in this formula I will tell you here. Now look carefully. For this tan A plus B, A plus B. Now instead of B we write there E. So A plus E, tan A plus A becomes here. Look here, tan A plus we write tan A because we are putting here value of B, that is A. Now here same way 1, here 1 minus tan A into tan A. Okay, now after this, here this formula becomes tan 2A, A plus A 2A is equal to, this becomes like this, tan A plus tan A means 2 tan A here upon 1 minus tan A into tan A, tan square E, sin A plus B is equal to sin A into cos B plus cos A into sin B. Okay, now here we put value of B, that is A. Instead of B we write here A is equal to sin A plus A is equal to sin A into, look here, B, instead of B we write here A plus here cos A, instead of B we put there A means sin A. Therefore we get here sin A plus A 2A. Now here sin A cos A, sin A cos A, addition, sin A cos A plus sin A cos A means 2 into sin A into cos A. Now cos A plus B, A plus B. For cos A plus B we write here original formula cos A cos B, and here we write minus sin A sin A into sin B. Now we put values. Cos A plus, instead of B we write here A is equal to cos A into cos, instead of B we write here A minus sin A into, here also same way, instead of B we write A. Therefore cos 2A is equal to, cos A into cos A means cos square A minus we write here sin square A. cos 2a is equal to, now we know that formula for cos square a. Cos square a means 1 minus sin square a, and this original sin square a, that is minus sin square a. Therefore cos 2a is equal to 1 minus sin square a minus sin square a, that is 2 times, therefore minus 2 sin square a. Now I will put here, instead of sin square a, I will put there 1 minus cos square a. Then we get here cos 2a is equal to, now cos square a we put as it is. Instead of this sin square a, I will put there 1 minus cos square e. Therefore our formula becomes cos 2a is equal to cos square a minus, internal sign changes, this plus becomes minus and this minus becomes plus, means plus cos square e. Therefore we get here formula for, another formula for cos 2a is equal to cos square a plus cos square a 2 times, therefore 2 cos square a minus 1.